example, just to get to the point, you may have to work on hundreds, and probably 5 or 10 of them get into production. So there is a lot of wastage of resources, and it's highly unlikely that if you don't have a good workflow, if you don't have cooperation within the organization, if you don't have a central repository of data, or at least a good connection between different repositories of data, that you're able to provide access to the right folks and then have a proper workflow to deploy that model into production, for example. So what are the barriers? So one thing is uncertainty as to what's going to happen next. That prediction is one of the biggest use case of machine learning. That's the most common. But on the other hand, something that is cool today may not be relevant tomorrow in 6 months. So executives have this fear as to, should I really buy into this tool? Should I really use this? Is this going to bring value to me or not, right? And things change at lightning speed, right? So as I said earlier, there are lots of tools out there. You have to make a decision what to use. You have to make a decision if you want to build something from scratch, and you have to understand that this may actually kind of leave you behind as well if your project is delayed, etc. Other problem is talent. Hiring talent, keeping talent in place, and making sure that you don't lose talent, right? So that's the biggest challenge that we have observed in the industry, and this was actually discussed in the panel this morning, just before lunch. So that nobody has really recovered from it. Nobody has really found a good solution for it. But every organization deals with it differently, depending on how their organization is laid out and what problems they are looking to solve. Another challenge is silos within an organization. So there are different departments within any organization. So what I've seen is, for example, even sales and marketing teams do not work together sometimes. So they don't know if marketing is actually generated any sales. One of the very early projects that I worked with a customer on was that basically sales and marketing data being brought together into one data mart from 2 different silos, right? So, and again, each department may have different preference for different tools, and that again creates problems because someone may be familiar with R, they might have developed they might have written they might have done multiple experiments, deployed a model somewhere. All the testing probably was done on their laptop, and then some other data engineer or a software engineer translated it into production API, for example, right? But if it was done in sales, some other department may not be able to use it because they just don't have access to that data mart, right? So that's a problem for IT and the data science teams. So here again, as I mentioned earlier, all these tools create problems because different teams use different tools. It's hard to provide access to different users. IT has a huge problem here where they want to make sure that role-based access controls are in place. So in some cases, they just create different silos for different departments. Departments are individually happy, but when, for example, there was a data science team that required access to a manufacturing yield analysis data set, and the core business of this organization is manufacturing. Like they manufacture some goods for themselves and other third parties, but the data scientists were not able to get access to yield analysis data sets because they were not part of the manufacturing group. That itself creates a roadblock for the organization to move forward and provide better yield for their manufacturing cycle, for example. So we have seen data scientists have to jump through multiple SSH tunnels or create multiple SSH tunnels through different gateways to get access to the right data set, just because IT will not let them run the same workload that they're running on their laptop on a particular cluster, for example. And executives on the other hand are always waiting, okay, provided them with all these tools. We have spent millions of dollars on storage and data processing tools. Where is the value in it? Like, I'm waiting for it. When will it come? And that usually never happens because data is siloed. There are individual rock stars who are working on smaller projects or things that cannot be reproduced, and that again creates challenge because if they are not able to reproduce the research or their experiments or their results, you cannot necessarily deploy your models in production with confidence because you're not able to reproduce the research or reproduce the experiments that you have done. And so this is what I was leading into. So there are unicorns in any organization who can take up these data science projects. They may be able to help you transform your organization to a certain extent, but they can only go so far, right? And just one person cannot really do everything. In any data science project, there are several stakeholders. And this is an example from one of our customers, right? So it cannot be that you rely on one unicorn, one genius who is going to solve all of the data science problems for you, even within a small organization. And it's a team sport. So you need a workflow, you need a tool or a set of principles to follow where it's collaborative in nature. It's not easy, but that's how most organizations who have a mature data science team do it that way, essentially. So, as I mentioned earlier, how can we actually achieve that, right? So, we have all these problems. To make sure we are able to solve this, we need to understand what do data scientists actually need. So there are data silos. We need to first either unify them or provide access to the data scientist so he has access to all of the data marks, or bring all of that data into one place, right? That's one. The other is build a meaningful pipeline where different stakeholders can engage in a secure manner. So IT is happy with the solution and ecosystem, and make it so that it's collaborative in nature, so that so you can even upgrade a data analyst as a data scientist in some cases. There are tools that allow you to automatically run different. It's so hot here, sorry. On the stage, it's really hot with this lady, and I apologize. There are tools out there in the market that allow you to automatically run different machine learning algorithms for, let's say, a classification problem, and you can have different metrics to kind of choose which experiment or test different experiments for model training and decide which one works better for you. That way, you're basically turning a data analyst who uses this tool into close to a data scientist, essentially. So, since there is a talent issue, you have to find. It's hard to find a core genius data scientist all the time. You can hire 2 of them and have, let's say, 5 data analysts who can support them, and all of this can be done in a collaborative manner. So that is the key. So you have to have an environment that provides a collaborative workspace. So what's Cloudera's approach here? So what we provide is we solve these multiple problems in 3 sets essentially. One is to alleviate or to approach the uncertainty area where how should I solve this problem? We have a service called Fast Forward Labs. They are basically a research wing. They specialize in bringing all of the academic research to solve business problems. And Hilary Mason is the founder, and she leads that group. I'm sure you have heard of that this morning from Nisha. And then we have Enterprise Data Hub, which is Cloudera distribution of Hadoop and the ecosystem tools. SDX is a recent introduction, was recently introduced. All it does is provide a shared meta source, so You may have access to data from either from on an on-premise cluster or on the cloud, and you have the same experience. And we provide to the data scientists and data analysts a productivity tool called Cloudera Data Science Workbench, which is similar to notebook-like environment, but on top of that, you are able to run multiple experiments. You are able to choose a particular model and then deploy it in production using a model as a function deployment of using REST API, for example. So I'm going to go quite quickly through some of the slides, just so that I can make some time for the demo of Cloudera Data Science Workbench. So Fast Forward Labs, as I mentioned, it is a applied research team. What they provide is a consulting service. It's led by Hilary Mason. She's quite famous in this area. She has like millions of Twitter followers. And they basically take academic research and apply that to solve business problems. Through this service, they don't tie you to any of the Cloudera ecosystem products. Their aim is to individually attack data science and machine learning problems and making sure that organizations make progress in that direction through the help of this team. There are many folks who have like double PhDs. It's just even crazy to imagine that. And they have kind of specialized in implementing machine learning algorithms or taking research papers that have been recently published in the last 6 months and providing a solution for business problems in the real world. So if you want to be in the cutting edge, this is the group you would want to talk to. So they also publish a quarterly report, and some of the topics that are covered are right here. So none of these are like really new or groundbreaking if you just look at the titles, but what's being published here is basically they've taken a couple of research papers that were published recently, and they've taken the methodologies and built an application out of it, right? So when you look at a research paper, academic research paper, it's all theory and results. Nobody can see the code. They basically went back, looked at what was discussed in the paper, implemented that solution, and there are demos available for you to play with that, and also that kind of provides credibility that they are able to do that to solve business problems, and they would come in house and solve problems for our customers. And with Enterprise Data Hub, which has this goal of bringing eliminating data silos and bringing all of the data in one place, we have Cloudera Enterprise Data Hub with SDX, which also now supports cloud storage with S3 and ADLS APIs for object store on the cloud, and security governance is basically part of the platform using Cloudera Navigator. We have another product coming up called Workload Management. That's Workload XM. That also helps you understand your workloads better and provides recommendation on how to queue your jobs, etc. All right, so let me just move on to the next one. So this is the key of this discussion, Cloudera Data Science Workbench. So why do we need another tool for data scientists or writing a machine learning code, etc.? So IT has always found this as a problem that data scientists want to install their own packages, their own dependencies across the cluster, and that creates a problem because you cannot entertain that in many cases. So one data scientist may come in and say, I want Python 2.3 and this particular library to be installed to run my, to deploy my model or even to run an experiment. Another one comes in and says, hey, I need Python 3, for example, and it's really hard to manage those dependencies in a distributed system. Also, sometimes data scientists basically just want to solve this problem to, they just want to run machine learning algorithms and provide value to the organization. So they just pull out the data from any kind of data repository. It could be your data warehouse, Enterprise Data Hub, whatever it may be, and then run programs on their laptop. Now this also creates problems for skewed data sets. So They may take a sample, they may not be able to take terabytes of data, for example, and run any kind of algorithm on a laptop, right? So what happens then is, it's possible that your data is skewed, you've created a model and you want to deploy that in production, and when you deploy that model in production, obviously the results you've got on your laptop are going to be different when you deploy it on a production scale with hundreds of terabytes of data, right? So that creates a problem where you don't get the right results. Now, to solve this, we have Cloudera Data Science Workbench, which provides secure access, and I'll go into details, but it allows you to achieve results faster in a better way, in a collaborative way. So, what it has built into it is a notebook-like environment that is launched via Kubernetes and Docker sessions. So we have an orchestration layer of Kubernetes, we have a container layer using Docker, and you can create different projects. Each project has its own team, for example, or you can have multiple teams on the side, and multiple teams have different projects, whatnot. And that allows you to kind of create siloed projects, make sure that the right team has access to the right code base. And also, as it integrates with EDH, you have Apache Sentry playing the role of role-based access control. So this particular team that has access to the right data sets can easily run jobs on the entire cluster rather than pulling data from enterprise data hub to their laptop, for example. So here's the architecture. So one thing I forgot to mention earlier was it also has an environment that looks very similar to Git. So you could basically pull in projects from Git and maintain version control through that. The key here with this architecture is